Hello everyone. So I welcome you again in my class. Today we are going to discuss abstract data type. We call it as ADT. This is a very important concept in computer science, and we normally refer this term when we talk about data structures, when we talk about computer algorithms. So in this lecture we are going to understand what is the ADT and what different kind of ADTs are available for us. So ADT is basically a mathematical model of data type. It's a mathematical model of data type. Now keep in mind when we talk about data type is something that refers to things. So when we talk about data type, it refers a set of values and it refers set of operations. Now set of values means it defines a range of values. So you might have you using different data types in the different programming language, like int is very fundamental data type, is a primary data type in C. So when I say int in C language, it defines a range of values. It allows you to use a defined range within this data type. So it goes from minus 32768 up to plus 32768. It consumes 2 bytes of memory space. Also, it defines a set of operations which are allowed on this data type. So you're allowed to do plus, minus, subtraction, multiplication, division. These are the different operations which are allowed with this data type. So when we talk about ADT is basically describes two things. It consists of data structures and plus you can say it consists of set of operations that is performed on these data structures. Okay, so ADT means set of data structures and the set of operations which we are performing on it. Okay, let's see more about ADT. Okay, so you look to the definition of ADT, you can find it is described as a set of objects sharing the same properties and behavior. Now, you can relate this definition with the definition of class, which is defined as a collection of similar object is a class. So class is basically, let me write it here. Class is a representation of an ADT. So you have been using class in a program, so which is actually a sort of ADT, and class defines two things. It defines the attributes. Every class must have some attributes which define the characteristics of this class, and also it defines behavior. Behavior are the operations or the functions which you defined inside the class. So here you can see when we talk of ADT must have some properties for the data, which is actually the attributes, and it also has the behavior or the operations or the functions which defines inside the ADT. So ADT must have two parts, properties and behavior. So how we are going to implement this concept in programming language? We have two terms that we have been using in programming language. One is called encapsulation and the other is called abstraction. These are the concepts which help us to implement the idea of ADT in our programs. Encapsulation and the other is abstraction. Encapsulation is basically a binding of this data elements and the member functions together into one structure. So we have data elements are there, we have member functions are there, and we are binding it together in a one block, and we are called it as a class. So class basically provides us encapsulation, and the main objective of encapsulation is data hiding. Data hiding means we don't want that our data to be accessed directly by the outside world. So we are doing the data hiding, and this is we are doing with the help of the access modifiers. So we have access modifiers in the programming language, like private, public, protected. So data hiding we are achieving with the help of this private access modifier. So it will actually hide the data to be accessed from the users or from the outside world. The second concept is abstraction. Abstraction basically provides the hiding of hiding the complexity. It basically provides a higher level view, provides higher level view to the user. So what does it mean? It means with the help of abstraction, we can hide the lower level implementation, we will hide the complexity, and we will not provide the entire details to the users. We only allow the users to just look to the objective of this function, and then you can use it directly. Normally, when we use any functions using a library, you are only concerning with the name of the function, the input it requires, and the output what you are getting. You are actually not allowed to see the entire definition, that what is the logic used inside it. This is all about abstractions. So hiding the complexity, hiding the technical details. Abstraction we are using most of the time in the our real life. Whatever the objects we are using, whatever the things we are using in our day-to-day life, it is actually provided to us in the abstract form. Like if you want to use a air condition in your room, so you only need to know that how to start this AC. You need to have a remote, and you know how to press the on button, and it will start working. It is not required for you to understand the entire technicality, that how the things are working behind the scene, and how you are getting this cool air. So likewise, all the things that we are using, it is provided to us in the abstract form. We are only concerned with the higher level view. If you want to switch to use the fan, you just look for the switch, and then you just switch on. You just press the button, and it start working. You will not uh, bothering, you are not caring that how the things are working, how this electric current goes to the motor, and how motor starts rotating, and then you are getting the air. So abstraction is an important concept, and we will see that how it is used with this abstract data type. So data items that we are using have two different views, or you can say format. One is called logical form and the physical form, or we have another name also, that is called internal and external. So logical form refers to external view, or you can say it basically provides a conceptual view to the user. What does it mean? It means it will provide you the conceptual details, that what are the attributes provided within the ADT, what are the operations provided within the ADT, what are the function which is provided by the given entity that is represented by any ADT. Physical form refers to the internal view, or you can say it deals with the implementation part. So it basically deals that how that actual data to be stored inside the memory, what are the different organization we are using to arrange our data, and how the data to be accessed by the user. So when we talk about the data type, we have a logical view of the data, and then we have a physical view of the data. So in this part of ADT, we discuss about the definition, the operations which are actually there inside the ADT, to make a conceptual view to understand what actually it provides to the user. And the data structure, basically a physical view, and it will deal with how the memory will be occupy to store this data element, and then what are the mechanisms we are using to access this data element. So data structure is basically the implementation of ADT. So data structure deals with the implementation part of ADT. With the help of this concept, we are actually implementing this concept. Okay, moving to next. Okay, so why this ADT is actually important for us? And when we say ADT, ADT means abstract data type. So here the term abstract refers that it provides only implementation independent view. What does it mean? It means that the user uh, does not allow to access the implementation detail. That's why it is called as ADT. And why it is important? Because ADT with the proper usage of data structures means if you carefully identify which data structure is suitable for your program, then you can improve the performance of your program. The efficiency of the overall program will be enhanced. You may observe later that if you have one problem, let's say problem P, and you are writing some algorithm to solve this problem, and to solve this problem by using the algorithm, you are using different data structures. You might be using priority queue, you might be using uh, a union find, or you might be using simply array. Now, for the same algorithm, if we use different data structures, you may realize that the performance may be varying. So it is very important for a programmer to identify the proper data structures to enhance or to improve the performance of the program. Now, when we talk about the ADT is defined using two terms, that is specification and design. Specification basically deals with, or you can say it describes how the operations behave, how the operations behave. So basically, it describes the logical relationship among the public part of that ADT, which are usually operations and the constants. So when we talk about the specifications, we basically deal about the we actually mean what are the operations which are being supported by the IDT. In specification, we also cares about the name of the operation, what is the name of the operation, what input it will take, what output it will provide, and we also identify what are the initial conditions which must be satisfied when the operations start executing. We also cares about the post requirement, post condition requirement, means after execution of this operation, what things must be satisfied. So this all comes in the specification part. Design part basically deals with the structure. You can say the shape, means how all the operations which is defined inside the entity and other constant variable which is actually required to make that entity workable or provides its meaning, how we can going to means give a shape of all these things, how we can bind all the things, that comes under the design. So when we talk about the architecture, we actually have two things. One is the operation functions, which is basically the operations which is defined inside ADT, and the structure, that is how we are going to bind all the operations together to define that ADT. Now ADT are of many kinds. You can just see some names mentioned here: list, trees, stacks, queues. These are the different ADTs that are frequently used as a data structures for solving different problems. And then we have we have categorized these ADTs into two parts. This is called standard ADT, and this is called non-standard or complex ADT. The basic difference between the standard and complex is, in the standard ADTs, uh, the ADTs that is defined using a design time, means ADT which is used using design time will be used as it is up to the implementation. Up to the final implementation, you are using with the same definition, whatever ADT you have defined using design time. But in the case of non-standard and the complex ADT, you might be using a different approach. You might be designing some ADT at the design time. So ADT you might be designing, maybe defining ADT you are defining at the design time, and at the implementation time you may be unwrapping this ADT. Now we are defining the ADT at the design time for getting some logical advantage. For some logical advantage, we are doing this. Now when I say logical advantage means, in some cases, to simplify the things at a design time, we frame some ADT to get some logical advantage. What does it mean? It means to simplify the analysis of the correctness of the algorithm. So initially we use ADT, but at the later stage when it comes to implementation, we actually going to do unwrapping of this ADT. So this is happening with this non-standard or the complex ADT. We are following this procedure. Okay, so moving to next. Okay, so to summarize what we have discussed so far, ADT is an abstract data type, and it's a collection of similar kind of objects like we are defining as a class. So if it is a type, then it's a collection of instances. If the ADT is a set, then it's a collection of element. If ADT is a class, then it's a collection of object. So ADT basically consists of the data structure declaration and the operation which are defined on this data structure. So this is something that we have been using in your programs. So ADT is defined as a class which you are using, which you have been using in C++ and Java. So this is the basic idea of the ADT, which is very important to understand when you are learning data structures as well as when you are learning computer algorithms. So this is the fundamental idea of ADT that it is required to be understood by any students of computer science who is studying data structures and algorithm. So we'll see you in the next lecture. Bye for now. Take care.